Hello, lovelies. Today is the makeup lesson if you missed on Monday or if you just want extra practice and a reminder of division. Um, so here we go. So just as a quick reminder, when we talk about division, there are actual names for the different parts of the numbers. The answer to a division problem is called the quotient. The big number that is being divided is the dividend, and how many equal groups you're putting it into is called the divisor. So when it's set up like this is how you would see the vocabulary words. Six is the divisor because it's how many groups we're putting it into. 24 is the dividend because that's how many things we have, and four is our answer. So if we have 24 Skittles and we want to divide them evenly between six people, everybody gets four Skittles. All right. So with that in mind, let's start with our first problem. We have 4 into 356. Now I set it up two different ways so that you could do the standard algorithm if you want to, or you can work on it with some teachers call this the big seven because of the big seven that is created there, but its technical term is partial quotient. Quotient being partial answers. So we're going to break it up into smaller answers. All right, go ahead and solve it and see what you come up with. All right, so I'm going to start with the partial quotient so that you can kind of see how that relates to the standard algorithm. If I have four groups, if I have 356, it helps with division with a lot of math. It helps to kind of put it into a scenario. So I'm going to say I have 356 pieces of bubble gum. I don't know why, but I do. I have 356 pieces of bubble gum, and I want to, my screen is going in and out. There we go. I want to make sure that I have four friends. That's right. I only have four friends. And I want my four friends to have them equally. So we're going to split the 356 into four equal groups. So I'm going to think, well, I can take 356. I can give everybody, can I give everybody 100 pieces of bubble gum? No, I can't do that, can I? Because that would be 400, and I don't have 400 to give. But I could give everybody 50 because 4 times 5 equals 20, and 4 times 50 equals 200, and I have at least 200. So I'm going to say I'm going to give everybody 50, and I just gave away 200 pieces of bubble gum. So I still have, do the subtraction here, 156 pieces of bubble gum left. I don't have enough to give everybody 50 more because that would take 200. Do I have enough to give everybody 30? If I do 4 times 3, that's 12. 4 times 30 is 120. Do I have at least 120? Yes. So I'm going to give everybody 30. So now I have 120 that are given away, and I have 36 pieces of bubble gum left. Well, 4 goes into 36. There's an actual math problem. 4 times what equals 36? Yeah, 4 times 9. So everybody's going to get 9 more. And that's exactly 36, and I have no pieces of bubble gum left. With partial quotient, that's a lot of math because you have to think multiplication, you have to think subtraction, and you have to think, now you have to think addition because you have to add these three up. The important part about this and adding these up is making sure the place value is in the right spot. So we've got 50, 30, the 3 is in the tens place. This 9 is in the ones place, so we have to add it with the ones. So we've got 9, 5 plus 3 is 8. So our answer is 89 with no remainders, no leftovers. So that's how partial quotient works. With the standard algorithm, I want to change my color. How about blue because the Seahawks play today? Go Hawks! Got green already? Now we're going with blue. Okay, so the way that division works with the standard algorithm is you start with the first number in the dividend. And you think, how many times does 4 go into 3? 4 times what gets us close but not over 3? Nothing. You could put a 0 there if you want to, but you don't have to. You can just move on to the next number because 4 doesn't go into 3, but it does go into 35. 4 goes into 35. How many times without going over? Well, let's see. I got 4 times 5 equals 20. Oh, that's way too little. 4 times 7 is 28. I can still go further. 4 times 8 is 32. My next one would be 4 times 9, which is 36. That goes over. So I have to pick the one that goes under but gets as close to it as possible without going over. So I've got 4 times 8. I'm going to put the 8 right above the 5 because that's what I was looking at was 35. And now I have to go 8 times 4 is 32. And I have to subtract that from the original here. So we've got 30, and now we have to bring down our next number. We have actually 3, not 30. We have 3 left over, and I have to bring down the 6. And now I'm looking at how many times does 4 go into 36? Not just the plain 6. We have to include the part that was the leftover from the last one. 4 goes into 36. Look at that. We already did this one. 4 times 9 is 36. So 9 times 4 is 36. We subtract that and we have nothing left over. All right. I'm going to give you the chance to do a couple more. Here's another one. Oh, my camera is having a hard time focusing. I think I need to have a colored paper. Does that help? Yep, that helps. Okay, go ahead and solve it. All right, so I'm going to solve it with the standard algorithm. I have to know my 8s. I have to know my 8 multiplication facts to be able to do this. 8 times something has to get us closest to 29 without going over. 8 times 2 is 16. I think I can go further. 8 times 3 is 24. Let's see if I can go any further. 8 times 4 is 32. 32 goes too high, so I have to pick this one, 8 times 3. I'm going to put the 3 up here, and I'm going to subtract. I'm going to do 3 times 8 is 24, so I'm going to subtract 24. 9 times 4 is 5. 2 minus 2 is nothing. I'm going to bring my 1 down. So now I have 8 goes into 51. How many times? Let me put my little arrow here. 8 goes into 51. Well, definitely not 4. 8 times 5 is 40. I think I can go one more. 8 times 6 is 48. Can I go one more? 8 times 7 is 56. Nope. So I have to go with the 8 times 6 is 48 because 56 goes over 51. So I'm going to go with 6 here. And I'm going to say 6 times 8 is 48. I'm going to subtract that. I have to borrow here because I can't take 8 away from 1. So I have to borrow. 8, 9, 10, 11. So that's 3. And I have to bring down my 2. Now I've got 8 times something gets it the closest to 32 without going over 32. It can be 32, but it can't go over 32. And we do have that one right there. So 4 times 8 is 32. I'm going to subtract, and I got 0. So my answer on this one is the quotient is 364 when you divide 2,912 by 8. Now, if you're doing partial quotient, one thing about partial quotient that's pretty cool is that there are so many ways that you could think about how to get those answers. The powers of 10 are a wonderful knowledge source for you for these things because you can think, well, I know I'm just going to look at the first 2 numbers here for the big ones. And it goes 8 times 3 is 24. So 8 times 30 is 240. 8 times 300 is 2,400. So do I have at least 2,400 there? I sure do. So I'm going to give everybody, this time of the scenario is going to be, I have $2,912 and I want to split it with my 8 friends, so 7 friends, myself included. So that's 8 total people. I want to share my wealth, my newfound wealth with everybody. So I'm going to start by giving everybody $300. If I give everybody $300, I have given away $2,400. I have to subtract that. 2 minus 0 is 2, 1 minus 0 is 1, 9 minus 4 is 5. I still have, and 2 minus 2 is 0. I still have $512 left. So let me think. If I think about my powers of 10, then I've got, let's see, if I want to get closest to 51 with just single digits, and then I'll use my powers of 10. So 8 times 6 is 48. Yeah, that's the closest I can get. So if I do 8 times 60, that's 480. Do I have at least 480 to give away? I was running out of room. That's why the zero is way up there. Yeah, so I'm going to now give everybody 60 more, and I just got rid of $480 more. 2 minus 0 is 2. I need to find out how much money I still have left. I have to borrow here. 11 minus 8 is 3. I still have $32. Well, 32 divided by 8 is a fact. So 8 times something equals exactly 32, and that would be times 4. So I now have no dollars left. But what I have to do now is making sure that my place value is in the right order. I have to add these up. But look at this, 360 and 4. So partial quotient is doing exactly the standard algorithm. It's just that this is a little bit less work when you figure out how to do it. So you got adding that, we've got 4, 6 plus 0 is 6, and 3. So our quotient is 364 in that way too. All right. The next one, I do have it set up as both methods, but I'm only going to do the standard algorithm. 12 into 780. All right, go ahead and solve it. All right, we're back. So I'm not as strong with my 12s. So my 12s, I might have to really do my sidebars here where I have my facts written down. Because I know up to, 12 times 1 is 12. 12 times 2 is 24. Then 36, then 48, then 60, then 72. I'm just skip counting by 12s. And this is times 3, times 4, times 5, times 6, times 7 would be 90. Wait. No, it's 84. I don't know where my brain went. See, I don't know my 12s as well. Times 8 is 96. Times 9 is 108. And I'm going to stop there because I don't have to go to 10. So if I have to go to a 10, then I'm too far over. I missed something. So 12 goes into 7 no times. 12 goes into 78 without going over 6 times. 6 times 12 is 72. So I'm going to subtract that. 8 minus 2 is 6. 7 minus 7 is 0. And I'm going to bring down my next number, which is 0. All right, so which one of these numbers comes closest to 60 without going over? Right, times 5. So we're going to put the 5 here. 5 times 12 is 60. And we have nothing left over. So 12 divided into 780 is 65. All right, last one. 15 into 3,948. All right, I don't know my 15s very well, so I'm going to write them down, but you go ahead and solve it. All right, so I'm going to write down my 15s. So 15 times 1 is 15. I don't feel like I need to write that one down because that one's a given. Then 15 more is 30. Then 45, so this is times 2, times 3, times 4 is 15 more, which is 60. Times 5 is 15 more, which is 75. Times 6, which is 15 more, which is 90. Times 7, which is 15 more, which is 105. Times 8, which is 15 more, which is 120. Times 9, which is 15 more, which is 135. Let me double check that because I don't usually do my 15s. So I just want to make sure that it goes up by 15 every time. So I think that's right. All right. So to do this one, 15 doesn't go into 3, but 39 is bigger than 15. So we can look here and think which one gets closest to 39 without going over. Well, the 2 does. So we're going to say 2 times 15 is 30, and we're going to subtract that 30. 9 minus 0 is 9. 3 minus 3 is 0. I'm only going to bring down the 4. Okay, which one of these comes closest to 94 without going over? Well, 90 does, and that's times 6. So I'm going to put the 6 up here, and that was 6 times 15 is 90. I've got 4 left over, and I'm going to bring down my 8. All right, which one of these comes closest to 48 without going over? Well, 15 times 3, which is 45. I'm going to subtract that, and I have 3 left over. I don't have anything left to bring down, so this is where you have a remainder you're going to have to deal with. In 5th grade, 4th grade, when you had remainders, oftentimes you would just write the letter R and the 3, but you're in 6th grade now, so we are going to be learning how to handle those in a different way. We're going to be ending these division problems with remainders, with fractions, or with decimals. For right now, I'm just going to tell you that you can end it with a fraction by saying 3 out of 15. So you could end it as 3 out of 15 for a fraction, or, and that would actually look bigger. I'm just doing it small because I was going to try to do the decimal. So it'd be, or 3/15. And that can be simplified to 1/5, but we're not going to get into that right now. Or you can end it with a decimal. And we're going to be working on that concept in a couple of days. All right. Thank you. Have a wonderful afternoon.